For more than 10 years, we have been hearing whispers of a mysterious planet lurking on the absolute fringes of our solar system. It resides at the very limits of the sun's gravitational grip, nudging distant icy worlds out of their natural paths as if they were nothing more than cosmic playthings. Though suggested by some data to be as massive as 12 Earths, we have never once laid eyes on this hidden giant. Yet, that does not mean we haven't seen the indelible footprints of its presence. So, if it truly is so immense, how is it that we have never managed to spot it? We possess the largest, highest resolution telescopes in human history, alongside an entire armada of sophisticated space-based observatories capable of peering into the atmospheres of worlds hundreds of light years away. How is it possible to know something so massive is orbiting our own sun, yet remain entirely blind to its existence? That is the profound question scientists have been scrambling to answer since 2016, when the Planet 9 hypothesis was first formally proposed. I'm Zachary Brighton, and you're watching Terminus. In this video, we will examine the elusive Planet 9 from the tantalizing clues that suggest it's out there, to the reasons why, even at up to 12 times the mass of Earth, it remains so impossibly difficult to find. Here on Earth, it can be deceptively easy to look for and find things. We see the vibrant colours of the world all around us, and the life that abounds in every nook and cranny. If we want to find something specific, and if that thing is close by, we simply need to look for it. If the desired object is further off, then perhaps a trip is in order to the local shop or market. And if we are not entirely sure what to look for, we can often rely on the expertise of others who are more familiar with what we seek, assisting us in our quest. But what if all you had to go on were a set of abstract clues left behind? What if you had to unravel a complex puzzle merely to locate what you sought? How much more difficult of a task might that be? If you were walking along a beach and saw a set of footprints, you would know instinctively that something had been there. But you would first have to put the scattered pieces together. Is the print in the shape of an animal or that of a person? How large is it? How deeply into the sand does it press? While somewhat simplistic, those are precisely the sorts of clues that astronomers and planetary scientists must piece together in order to find the elusive Planet 9. We possess no material clues. We have only the footprints left behind by its immense mass. And though this might sound like an impossible task to accomplish, we've actually been successful doing exactly that for nearly 200 years. The discovery of Uranus in 1781 by German-born British astronomer William Herschel marked a major turning point in human history. It was the very first time a planet had been discovered using a telescope, whereas mankind had been fully aware of the 6 inner planets for thousands of years. It was a systematic survey conducted of the night sky by Herschel that allowed him to accidentally stumble upon this peculiar ice giant on March the 13th, 1781. However, it was well known by 1820 that something was not quite right about the orbit of Uranus. It systematically deviated from the trajectory predicted by Newtonian physics. At certain points in its journey, it would inexplicably speed up, while at others, it would lag behind. It was soon hypothesized that a massive, unseen planet further out was the direct cause of these orbital perturbations, leaving invisible footprints in the cosmic dark. 2 brilliant mathematicians, working entirely independently on opposite sides of the English Channel, set out to solve the mystery. In 1845, John Couch Adams of Cambridge University, at just 26 years old, calculated the mysterious planet's position to within 2.5 degrees of accuracy, a truly remarkable feat in an era when every complex calculation had to be painstakingly done by hand. His contemporary across the water, the French mathematician Urbain Le Verrier, working in Paris, computed the planet's position with an astonishing 1 degree of accuracy. On September the 23rd, 1846, the planet Neptune was officially discovered at the Berlin Observatory, sitting precisely where Leverrier's maths said it would be. This monumental find proved once and for all that the movement and order of the heavens could be reliably predicted using maths. It demonstrated that major discoveries could be made using nothing more than a pencil and paper long before a telescope was ever aimed at the stars. Understanding how Neptune was discovered is all well and good, but what does any of that have to do with Planet 9? Well, where finding Neptune was akin to finding a needle in a haystack, finding Planet 9 is more like trying to find a needle in an entire field of haystacks. But just like Neptune pulled on Uranus and gave mathematicians those vital clues, it is thought that Planet 9 may leave its mark in the exact same fashion. Beyond the orbit of Neptune lies the Kuiper belt, a vast ring of ice, asteroids, comets, and small planetesimals that circles the entire outer solar system. The most famous resident of this region is, of course, the dwarf planet Pluto. However, there is a specific group of these objects that simply are not like the others. And when something in space does not add up the way it is supposed to, there is usually a very good reason why. This is Sedna, one of the most distant bodies in the solar system. It is roughly 1,000 kilometers across and unimaginably cold, with a surface temperature that never rises above -240 degrees Celsius. Its orbital path takes it to the very edge of our solar system, out to a staggering distance of 937 astronomical units from the Sun, only to eventually swing back to a much closer 76 astronomical units. It takes Sedna a mind-numbing 11,000 years to make just one complete orbit. Like Sedna, there are several other distant bodies that follow a remarkably similar trajectory. These objects are far too distant to ever be influenced by Neptune's gravity, and this is where Planet 9 comes in. It is hypothesized that a super-Earth-sized planet is responsible for shepherding them into extreme orbits that are so similar, a phenomenon known as orbital clustering. This mechanism aligns the objects along similar orbital planes, matching both the angle of their tilt and their perihelion, the point where they run closest to the Sun. According to the original authors of the Planet 9 model, Konstantin Batygin and Mike Brown, the odds of this clustering happening by mere chance are less than 1%. Furthermore, the latest data analysis in 2025 narrowed the likelihood of this alignment being a random fluke down to just 0.2 to 0.4%. Many in the scientific community agree with those striking numbers, which explains exactly why the hunt for this elusive planet remains one of the most compelling mysteries in modern astronomy. All right, we have some compelling evidence that Planet 9 is out there in the distant part of the solar system, dislodging smaller dwarf planets and other objects as it goes about its orbit. The latest estimates place Planet 9 roughly 290 to 300 times farther from the Sun than the Earth is. At that range, it takes light from our Sun more than a day and a half just to reach such a distant world. And that is the primary problem when it comes to finding Planet 9. From such incredible distances, the light from our Sun would barely register as a faint flicker. Any light that reflected back would be extremely dim and difficult to detect, which would make finding such a distant and dark object nigh on impossible with current technology. This is notwithstanding special circumstances, such as a series of stellar occultations, which might serve to reveal Planet 9, but even that would take years, if not decades, to detect within the vast amounts of data currently available. But hope is on the horizon. as the Nancy Grace Roman Space Telescope is scheduled for launch in September 2026 and is specially designed to detect the faint infrared glow of dim and distant objects like Planet 9. There is also the Vera C. Rubin ground-based telescope in Chile, which just came online in 2025 and is projected to greatly aid in the search. There is a growing anticipation that with this newest set of telescopes, it will only be a matter of time before we finally locate the wayward ninth planet of our system. While the evidence for Planet 9 might seem compelling, some might even say overwhelming, the hypothesis is not without its critics, and the points they raise are hard to ignore. For starters, detractors point out that what we perceive as orbital clustering might merely be an artifact of observational bias, caused by the limited scope of our surveys and a small sample size. They argue that telescopes cannot observe the entire sky equally, meaning astronomers have focused heavily on only small specific regions. There may be many more bodies scattered throughout the outer solar system in a completely random pattern that we simply haven't detected yet. The thinking is simple. Given a random distribution of minor planets, if you point a highly sensitive telescope exclusively at a region believed to be affected by Planet 9, you will surely find exactly what you are looking for. Critics argue you could get the same results regardless of where you pointed the lens. Between 2013 and 2017, the Outer Solar System Origins Survey used telescopes from all around Earth to locate and track trans-Neptunian objects, or TNOs. The survey used advanced computer modelling to explicitly account for any potential observational biases, and what the study found was striking. There was no statistically significant evidence for orbital clustering. The more than 800 new bodies discovered were randomly distributed across the sky, meaning a massive hidden planet wasn't needed to explain the data. The clustering observed in earlier studies was confirmed to be a mere artifact of observing the exact same region of the sky repeatedly, according to critics of the Planet 9 hypothesis. So where does that leave us? Is there a planet somewhere in the outer solar system that's between 4 and 12 times the size of the Earth? When first proposed by astronomers Konstantin Batygin and Mike Brown, the idea sparked massive debate across the scientific community. Even if it turns out that Planet 9 was nothing more than an illusion of biased data, the discoveries about the outer solar system, the refinement of how our surveys of the sky are done in order to better eliminate such biases, and even the advancement of certain theories about solar system dynamics have all come about largely due to the debate surrounding whether a ninth planet orbits our Sun or not. Many times, in various scientific fields, it is topics such as this whereby the biggest advancements are made, even if the initial findings turn out to be incorrect. Debates about if something exists or how something works are what spark researchers to ask different questions, and hopefully start filling in the blanks with answers we never could have predicted. As of 2026, Batygin and Brown still maintain their orbital clustering model is accurate and have done their own research with the OS/SOS data that seems to support at least some of their claims. The only true way for the debate to be settled once and for all is by the physical discovery of Planet 9. Short of that, the debate will continue to go back and forth, which will undoubtedly spur new orbital surveys and new advances in how we refine and process that data, which in turn will benefit future observatories and space-based missions. And from the outside, it might seem like a messy process, but the truth is, this is how science and our understanding of the cosmos continues to grow.